The metric system is the unit of measurements that's used throughout the rest of the world. The United States does not use the metric system, per se. Our road signs, we all use our standard measuring system. Whenever you drive past a road sign that's measuring distance, it'll say miles, or it'll say miles per hour for the speed limit. And it's extremely important for us to realize that our measuring system is maybe not quite as easy as the metric system is. And we're going to see more today as to why our measuring system is not quite as easy as what the metric system is. Each measurement within this system contains a base unit, so the liter, meter, gram. There's a few other ones. Those are kind of the basic ones that we'll typically talk about. And then attached to those is a prefix. So the prefix gives meaning to the amount of that unit. So units, the units that we have, they help to explain what it is that we're measuring. The prefix then gives an amount to what we're measuring. The one reason the metric system is pretty easy is because it's based on powers of 10. So simply we can move the decimal point to the right or to the left to make simple conversions. So for example, 5 kilometers equals 5,000 meters, which also equals 5 million millimeters. And each conversion is made by simply moving the decimal point to the right or the left. And we're going to see more as we continue in this. We're going to see more how that is extremely easy to do based on where we're moving from and to. So when I was a kid, the metric system was kind of popular. In our country, we were supposed to all switch over to the metric system. When I was probably about your age, actually. Every time I go to science class, the teacher would tell us, you need to learn the metric system because we're switching over to it. You guys all have to know the metric system. You're going to see it on the road signs eventually, and it's going to say instead of miles to the next town, it's going to say kilometers. Everyone's got to know it, so let's learn it. And then in the next breath, the teacher would be like, you gotta have it. You gotta know all this addition and subtraction stuff because you can't depend on a calculator. You're gonna walk around with a calculator everywhere you go? I don't think so. You aren't gonna walk around with a calculator everywhere you go. You gotta know your math. You gotta know your addition and subtraction. Little do they know, I walk around with a calculator every day. It's called my phone. My phone has a calculator on it, along with numerous other apps that help me every single day. So, I'm not going to be the teacher that tells you, oh, well, you got to learn the metric system because in 5 years we're going to switch over to it in our country and it's going to be so much easier because we're going to use the metric system. So this chart is inside of your notes. It shows common prefixes that we would find in the metric system. The common prefixes also have a symbol that's associated with them. So, for example, the symbol right there at the top of the chart, uppercase T represents tera, uppercase G represents giga, uppercase M represents mega, and we work our way all the way down to the unit itself. And then everything below the unit itself, all of those are smaller than the unit. So our units are liter, meter, gram, etc. Everything underneath the no prefix unit, that would be a smaller increment than what the unit is itself. Okay, so for example, micro's up there. Micro would be smaller than whatever the unit is we're measuring. This slide shows the common units. Common units that we will typically talk about with the metric system are liter, meter, gram, joule, second, and Pascal. Each of those have a symbol associated with them. The units give us what we are measuring. So for example, liter is measuring volume. Meter is measuring distance or length. A Pascal is measuring pressure. So our units give meaning to what we are measuring. The prefix gives meaning to the amount that we are measuring. So we combine prefixes and units. So values in our metric system, they contain a unit, and the units are typically preceded by a prefix. Not necessarily always, though, because if we were measuring in meters, then we wouldn't have a prefix in front of it. So this list of prefixes is not all inclusive. There are others outside of what I'm putting on this list. But our prefixes, tera, giga, mega, kilo, hecto, deca, deci, centa, milli, micro, nano, are units, liter, meter, gram, joule, second, and Pascal. If I take a prefix of milli and I combine it with the unit gram, I get a milligram. And to correctly write out a milligram, I would write mg. M for milli, G for gram. Next one, prefix kilo. Combine the prefix kilo with the unit liter, and I get a kiloliter. And in order to correctly write out the symbol for that, I would combine K and uppercase L, so it would be KL for kiloliter. And finally, a centa combined with a meter gives us a centimeter. Combine the symbols, cm, centimeter. So I'd like for you to write down in your notes our metric map. This should be familiar to you. We've seen this before. And our metric map is used to help guide us through the metric system. We start with a kilo, go to a hecto, a deca, and then our units, whether it be a gram, liter, meter, Pascal, second, whatever they are. Deci, centa, and milli. When using the metric map, we identify our starting point. So it's the number followed by a prefix. So we should have a number inside of our conversion, followed by a prefix or a unit. That's what we're looking for to identify our starting point. Second step, we're going to count the number of steps or places to the prefix or unit we want to get to, so our final destination. And then finally, our third step, we're going to move the decimal point, the number of steps between the 2 points, in the same direction. So we're going to go the same direction we moved on our metric map. So we've got some practice problems we're going to do together in class. Practice problem number 1, how many milligrams are in 3.6 kilograms? Number 2, convert 15 liters to centiliters. Number 3, how many hectometers are there in 12.67 millimeters? Number 4, convert 128,650 milliliters to decaliters. And then finally, number 5, Jason ran 1.61 kilometers. How many meters did he run? So practice problem number 1. Go ahead and write this down inside of your notes or on a margin somewhere where you can practice this with us in class. So we're going to start with our metric map. And this is just a tool for us to use to try to help ourselves out. Some of your brains may go ahead of being able to just use this tool. Some of you might be able to think through this without the tool. It's just an opportunity for you to work with something to help you out. So we're going to start with kilograms. That's our starting point. We're going to go to milligrams. So that's our final destination. So our direction, we are moving from left to right. So we're moving to the right. And then we got to count out the number of steps. The number of steps go from kilo to hecto is 1, 2, 3, 4, 5, 6 steps. Okay, so I go in the direction to the right, 6 steps. So I have 3.6 kilograms as my starting amount. I'm moving the decimal point to the right. 1, 2, 3, 4, 5, 6 places. That gives me 3,600,000 milligrams. Make sure that you change your units at the end because we went from kilograms to milligrams. Go ahead and try practice problem number 2 on your own. Convert 15 liters to centiliters. So here you go. Let's walk through this together. We start with our chart, our map. we're starting with liters, so we're converting 15 liters to centiliters. So our starting point is liter. We're going to centiliters. So that's our final destination. What direction are we moving in? We're moving in the right. The number of steps? 2 steps. So we start with 15 liters. We move it to the right 1 place. 2 places. We should have gotten 1,500 centiliters. Practice problem number 3. How many hectometers are there in 12.67 millimeters? Give it a try on your own. So here's the chart to help you out. So if we are starting with 12.67 millimeters, our starting point is milli, we are going to hecto. Alright, so our direction is from right to left, so we're going to the left. Our steps are 5. From milli to second is 1, from centi to deci is 2, to meters 3, to decas 4, to hectos 5. So we're going to move the decimal point 5 places to the left. That's the direction we're going. So you should have 0.0001267 hectometers. You should have 3 zeros, 1267 hectometers. Practice problem number 4. Try it on your own. Convert 128,650 milliliters to decaliters. Here's the chart to help you out. And just a hint, we're going to start with milli. So we're starting with milli. That's our starting point. We are going to deca. That's our final destination. Our direction is from the right to the left, so we're moving toward the left. The number of steps should be 4. Milli to centi is 1, centi to deci is 2, deci to liter is 3, liter to deca is 4. So we move the decimal point to the left 4 places. 1, 2, 3, 4. We should get 12.865 decaliters. Last practice problem. Jason ran 1.61 kilometers. How many meters did he run? So we're going to start with kilo. We're going to go to meter. So our direction is to the right. The number of steps is 3. Move the decimal point to the right 3 places. 1, 2, 3 places. 1,610 meters. Helpful acrostic. A way for you to remember this. K, hit, dog, arf, dog, can't, move. K hit dog, arf, dog can't move. You can try to create your own mnemonic device for that.